obviously skip question number 1. It's the section that we skipped, and we don't all have the TI graphing calculator. So questions 2 and 4 are essentially the same question. You just are getting the same question twice, where they want you to eliminate the parameter. You're going to follow the basic steps that were outlined in your core packet. So solve the first equation for t, substitute it into the other equation, simplify it, and then identify it as linear, quadratic, or other. Okay? Right now, it's going to be linear or quadratic, but have an open mind that did we see one that was cubic? You might have 1 to the 3rd power. That would make it cubic, okay? But it's like 90% of them at this point are either linear or quadratic. Okay, so for number 2, the first equation was x equals t minus 1. So to get the t by itself, you do the inverse operation. So the inverse operation is subtracting 1 to both sides. You get t is equal to x plus 1. Everything that t is equal to, you're going to substitute it into the other equation. So you're going to take that x plus 1, sub it right there for that t, so it ends up being squared. X squared plus 2x plus 1. You can use a little box thing if you need to, or just FOIL. And then make sure you add a little 2 after, so when you combine those two, you get x squared plus 2x plus 3. That's simplified as far as it can go, okay? Because it's squared, it's quadratic. If you were to graph it, it would look like a parabola, okay? Any questions on box number 2? Good? All right. Skip box number 3, jump over to box number 4. Same directions, okay? Essentially the same question as number 2. So you're going to take the first equation, the x equals 3 minus 2t. This one has 2 steps, so we're going to subtract 3 from both sides, divide both sides by 2. That gets us negative 1/2 x plus 3 halves. Then we're going to substitute that in to the other equation. So we're going to have negative 4 minus 1/2 x plus 3 halves. Then we combine any like terms. Let's see. These two would be our like terms, right? And that simplifies down to negative 1/2 x minus 2.5. That x is to the first power, so it makes it linear. All right. Box number 5, which wants us to convert the polar point to rectangular form, and you will need your unit circle for this, okay? So it's going to be given to you in the r theta form. You need to turn it into the xy form, all right? So for the formula we're going to use for x is the r cosine of theta. So the 4 plugs in for r, 5 pi over 4 plugs in for theta. We find it on the unit circle. It's negative rad 2 over 2. Multiply that by 4, so the 2 goes into 4 twice. And there's a negative, so I just pulled the negative out front. So it should be negative 2 rad 2. Sometimes it happens that they're both the same, which is the case here, okay? Even though we're using r sine of theta, okay? So again, we plug in the 4 for r, 5 pi over 4 for the theta. It's the same when you go on the unit circle, so you get the same answer twice. Okay? Other direction, and convert the rectangular point to polar, okay? So we're going to use the 2 formulas we saw yesterday. R equals the square root of x squared plus y squared. So we plug in the x value here, which was rad 3, and square it. We plug in the y value right here, which was 1, and square it. Add them together, and then take the square root. To find the theta value, we plug it into the inverse tan of y over x. So this one would be 1 over rad 3. Punch it in the calculator. You should get 30 degrees. Okay? Notice that rad 3 and positive 1 are both positive, so that's going to put it in which quadrant? 1, okay? So 230 is correct, which quadrant 1 should be, okay? All right, part B says give 2 other polar coordinates which describe the same point. Make one of the points have a positive R, and the other have a negative R. Okay, so I just did multiples. Now, this first one, I just added 360, which gave a positive and a positive. This one is not between the negative 360 and the positive 360. Remember yesterday how we got 4? 1 was given, and we found 3 more. This one has 1 given, and they're asking us to find 2 more. Oh, so I did 4. So I just did lots of possibilities, okay? So if you take the 30, subtract 360, you get negative 360. You want the negative values. 1 should be at 210, and 1 should be at negative 150. Okay? Any questions on box 5 or 6? And label the following 4 points. Okay? So A should be at 2, 5 pi over 4. So you would definitely want to use your unit circle on this, right? Why not? You have access to it, use it. So 5 pi over 4, it's going to be right here. 2 units out, so there's your A. B is at 3, negative 2 pi over 3. So 2/3 pi would normally be...
Yeah, it would be in the third quadrant.
Did I mess one up? I don't think so. Okay, I'll check it in just a second, but what did I do? That would make 6 4/3. Is it because this is negative?
Because 2 pi over 3 is there, but then you would go back the opposite, right?
You would, oh, it would be down here. I messed up B. So it should be the third one out. It should be there, yeah? Oops. Yes. Yes, just a second. All right, let's do C, and then we'll come back to B. All right, so 7 pi over 6. C. Did I put that? No, okay, so 7 pi over 6 is going to be over here, but it's negative 1 plus 2. So we're going to go 1 that direction. And then D is negative 5 pi over 4, which would put it positively here. Oh, did I put that one in the wrong spot too? No, because it's negative. Sorry, because that's negative. So that's correct. Puts it over there. Like, oh man, they're all messing me up. Okay.